March 2024, marine biologist Jennah Tucker is aboard Naturaliste Charters in the Bremer Sub-Basin off the southwest coast of Australia. The orcas she has been watching for most of the day are doing what transient orcas do on a slow afternoon. Long dives lasting up to 8 minutes, surfacing briefly, then down again, searching. Around 1 in the afternoon, a large splash breaks the pattern. The orcas surge forward, increasing speed, moving in formation toward the continental shelf. Tucker's vessel follows them for 11.5 kilometres as the water beneath shallows from over 800 metres to just 80. She expects a beaked whale to surface. That is the typical prey for this population, and beaked whales are what these orcas usually take. What comes up instead is an arched back, then a vast triangular tail. 5 sperm whales, 4 adults and 1 juvenile, have come from depth and are already grouping, rotating into a tight circle at the surface, heads drawn inward, tails sweeping outward in every direction. Approximately 30 orcas circle the formation. They don't enter it. After some time, without a confirmed kill, they move on down the shelf edge. The sperm whales remain tightly grouped at the surface for another hour after the orcas have gone. Tucker's account, published on the Ocean's Blueprint research site, is one of a small number of field records that document the same pattern across decades and ocean basins. Orcas arrive, the formation assembles, and the orcas leave. What makes this pattern significant is what it reveals about the sperm whale's defensive architecture, and why the ocean's most effective pack hunters consistently find themselves on the outside of it. Killer whales prey on at least 20 cetacean species, 14 pinniped species, sea otters, dugongs, sharks, and seabirds. Off South Africa and in the Gulf of California, researchers have documented them surgically extracting the livers of great white sharks, locating the organ, consuming it, leaving the carcass largely intact. Multiple coordinated pods have killed adult blue whales in events documented in marine mammal science. NOAA classifies them as the largest predators in the ocean. That is the baseline threat. Now hold it against what Tucker witnessed, and against a small collection of similar accounts stretching back through the literature. Accounts of these encounters circulate widely online with an attached figure. 10 minutes is typically how long orcas attempt the hunt before abandoning it. That number is worth examining, because it's the wrong figure attached to the right phenomenon. The specific approximately 10 minutes figure in peer-reviewed literature comes from a 2015 study by Pittman and colleagues documenting humpback whale group defense, not sperm whales. For actual orca sperm whale encounters, the documented durations run considerably longer. A 2013 encounter off southern Sri Lanka lasted approximately 30 minutes before the orcas disengaged, with the outcome uncertain. The Bremer Canyon interaction ran for well over an hour. In October 1997, approximately 35 killer whales attacked a pod of 9 sperm whales around 130 kilometres off central California. That engagement lasted approximately 4 hours, involved 16 separate attack bouts, and ended with 1 adult female sperm whale dead. So the question isn't really the stopwatch. The correct question is, what determines whether orcas leave without a kill? In a proportion of documented encounters, including some that run considerably past an hour, they do exactly that. And in each of those cases, the sperm whales were doing the same thing, assembling a specific geometric formation that makes the orca's primary tactic structurally difficult to execute. Killer whale cooperative hunting has been documented across dozens of prey species.
Despite the variation in technique between populations, the wave washing of Antarctic type B orcas, the shallow beach hunting of Patagonian transients, The underlying logic against large prey is consistent. The operative step is separation. Against grey whale calves in Monterey Bay, a 2024 study published in PLOS One by Higuera Rivas and colleagues documented a formal sequence. Orcas herd the cow-calf pair, bite the calf's pectoral fins and flukes to slow it, then drive the calf away from its mother. Against dolphins, transient pods flank a large school, push one animal to the margins, then attack the isolated individual from below and from multiple sides simultaneously. A synthesis chapter on killer whale predation summarizes the logic against large baleen whales in a single line. They usually try to isolate a single animal and chase it. Prey isolation is the prerequisite because it removes the one resource a large prey animal has that orcas can't easily neutralize: the collective geometry of the group. A grey whale calf separated from its mother is a roughly 1-ton animal surrounded by 4-ton predators working in relays. The same calf, flanked by its mother and 3 adults in close formation, is a fundamentally different tactical problem. The Biological Review's classification of orca cooperative hunting mechanisms identifies prey isolation and containment as a named, documented tactical step. Once isolation fails, so does the attack's efficiency. For sperm whales, the documentation on this point is explicit. In the 1997 California attack, the most thoroughly documented orca sperm whale predation event in the scientific record, published by Robert Pittman, Lisa Balance, Sarah Mesnick, and Susan Chivers in Marine Mammal Science in 2001, with 289 subsequent citations. The orcas ran 16 separate attack bouts over 4 hours, all working toward the same objective. The formation held most of the time. When orcas finally succeeded in pulling one individual away from the group, that animal was killed and consumed. Separation was the kill condition. The paper's framing is unambiguous on this point. Pittman's diagram caption for the formation reads, "Geometry for an unselfish herd?" Sperm whales form a rosette with their heads together and tails pointing outward. The geometry is what the orcas were working against the entire time. The formation has a name, a published origin, and a specific spatial logic that has been documented across 6 decades of marine mammal research. In 1962, Japanese cetacologist M. Nishiwaki published a description of sperm whales circling a harpooned group member, heads drawn inward, tails radiating outward. The arrangement, viewed from above, resembles the petals of a marguerite daisy. Nishiwaki named it accordingly, and the term has persisted in peer-reviewed literature through every subsequent observation. Caldwell and colleagues documented predator-linked marguerite formations in 1966. Weller and colleagues published detailed field observations in 1996. Pittman's 2001 California paper describes the formation of a rosette, marguerite, heads together, tails out. In 2016, Ponampalam and colleagues published an observation from the waters off Muscat, Oman, in Aquatic Mammals, describing sperm whales positioning themselves in a circle at the surface in a manner akin to the spokes of a wheel, with their heads together on the inside of the formation and their tails radiating outwards. Spokes of a wheel. That geometric language is precise. Both rosette and marguerite formation appear interchangeably across marine mammal science and aquatic mammals, the 2 primary peer-reviewed journals covering this material. The formation isn't a folk observation or a social media claim. It has been named, diagrammed, and redescribed by independent researchers across Australia, California, Oman, Sri Lanka, the Gulf of Mexico, and the Galapagos. The calves go in the center. This is documented independently across multiple sources. Weller and colleagues confirm that calves are often directly in the center of these formations. Ponampalam's Oman observation notes vulnerable individuals positioned in the interior. Gamel's 2015 Sri Lanka paper confirms calves benefit from being placed in the middle.
The geometry puts the most vulnerable animals at the point of maximum protection, surrounded by adults on all sides, inaccessible without first passing through the perimeter. The adults face outward, with their tails aimed at every approach angle simultaneously. An orca approaching from any compass direction faces the caudal end of at least one adult sperm whale. Whitehead's 2003 synthesis, Sperm Whales, Social Evolution in the Ocean, describes what the orcas actually do in response. 3 or 4 adult killer whales are rapidly circling just outside the rosette. They circle. They don't enter. The formation isn't static. Weller and colleagues document that it waxes and wanes, compressing and widening in response to threat intensity. Groups of 8 or 9 animals form the rosette arrangement. Larger aggregations shift into what Pittman terms a flotilla or phalanx, a shoulder-to-shoulder mass that achieves the same perimeter effect at scale. In one documented case off southern Africa, approximately 50 sperm whales coalesced in apparent response to 5 killer whales. The defensive architecture scales with the threat level and available bodies. There is also a 3-dimensional variant. Weller and colleagues describe 3-dimensional marguerites, animals pitch-poling with heads at the surface and flukes suspended below, still maintaining the head's inward orientation in the vertical plane. Ponampalam's 2016 Oman observation includes individuals in the center oriented vertically, with their bulbous heads protruding above the surface. The formation adapts to 3-dimensional space. Orca attacks don't come only from the horizontal plane, and the geometry accounts for that. Gemmell characterizes the formation in the 2015 Aquatic Mammals paper as an all-or-none strategy, one that provides uniform coverage to all members while placing calves centrally, but also places every participating adult on an exposed perimeter. Each member is simultaneously defender and defended. What the rosette achieves mechanically is the conversion of a pack hunting scenario, where orcas can direct coordinated force at a single isolated target, into a perimeter siege scenario, where every approach vector is occupied by an adult sperm whale with nowhere to retreat. For orca pack tactics, that conversion is decisive. Step 1 of the isolation sequence requires finding an individual that can be separated from the group. The rosette presents no such individual. Every adult is positioned so that moving toward any one of them moves you toward the flukes of several others. There is no unguarded flank. The formation doesn't just protect the calf in the center, it structurally denies the precondition for the attack. 2 caveats belong here. The rosette can be breached. The 1997 California encounter proves it. With 35 orcas working in coordinated waves over 4 hours, they did pull one individual away from the circle and killed her. The formation is a powerful but not absolute defense. Its effectiveness isn't in making kills impossible. It's in making each successful separation expensive enough and time-consuming enough that in a proportion of encounters, the orcas stop before achieving one. The second caveat concerns the formation's size dependence. 3 orcas killed a small sperm whale off Guanaja, Honduras in 2023 in approximately 20 minutes, with no viable rosette possible. The target was under 20 feet long and without enough group members to close a defensive circle. The formation requires bodies. Without enough adults to maintain the perimeter, the geometry fails, and the defense fails with it. The tail flukes themselves are a significant part of why breaching the formation costs as much as it does. Adult sperm whale flukes span approximately 4 to 5 meters tip to tip, the largest fluke surface area among whale species, driven by what biomechanical studies describe as extremely strong caudal musculature. Thrust power in large cetaceans scales predictably with body mass. A sperm whale redirecting that caudal force against an approaching predator is producing a very different impact load from the same movement in a dolphin. No peer-reviewed study has produced an instrumented measurement of sperm whale fluke strike force specifically against a predator, and no necropsy report documents an orca death definitively attributable to a sperm whale fluke. Qualitative assessments in the secondary literature describe potential for strikes capable of seriously injuring attacking predators, and the mass involved supports the general assessment. This isn't a weapon of negligible effect.
But the specific claim that a single strike can shatter bone isn't supported in the primary literature, and it shouldn't be stated as established fact. What the literature does support is the tactical geometry of the threat. In Tucker's 2024 Bremer Canyon account, the sperm whales were actively fluke swiping, directing their tails outward during the engagement. To reach the interior of the formation, an orca must pass through or around multiple 4 to 5 meter flukes simultaneously from multiple directions. The wound and withdraw pattern documented in the California attack waves of 4 or 5 animals, striking and retreating rather than pressing sustained contact, reflects exactly this geometry. Extended contact with the formation's exterior puts each attacker simultaneously within range of multiple adult flukes. The short, sharp bouts aren't a tactical preference. They are a concession to the formation's physical structure. The formation's defensive geometry creates the perimeter. Alloparenting determines how reliably it's held. Sperm whale calves can't dive as deep as adults. A foraging mother descends for minutes to hunt squid at depth. During that surface interval, the calf is vulnerable. Whitehead's 1996 study in behavioral ecology and sociobiology, covering data on groups with calves, demonstrates that adults stagger their dives, coordinating timing so that at least one adult is typically present at the surface with the calf during a mother's foraging bout. This isn't passive proximity, it's active behavioral adjustment documented across multiple groups in the field. Giro and colleagues' 2013 study in marine mammal science describes sperm whale calves as social hubs within unit networks and hypothesizes that the primary function of permanent social relationships among female sperm whales is to provide allomothers. The social architecture of the group is partly organized around ensuring the calf has multiple committed defenders, not one. In a defensive context, this means the rosette's perimeter is held by adults, each carrying an established behavioral investment in the calf at the center. The 2001 Pittman account confirms this in action. When an individual was pulled from the California formation, non-mother adults left the circle to flank the isolated animal and guide it back. Alloparenting in that moment wasn't social warmth. It was a documented tactical intervention under active assault. A precision note: the 2019 study by Conrad and colleagues in behavioral ecology found that allocare intensity correlates with kinship. Closer maternal relatives provide more intensive care. The "every adult defends every calf with equal intensity" framing overstates the evidence. The accurate claim is narrower, but still tactically significant. Defensive commitment is distributed across multiple adults, not concentrated solely in the mother. The perimeter has no single point where all defensive motivation is absent. For an orca strategy that depends on finding a less committed defender, a moment of hesitation, a gap in the circle, multiple distributed defenders with varying but non-zero motivation present a substantially harder target than a single mother attempting to shield her calf alone. The formation also benefits from advance notice. Sperm whale echolocation clicks reach source levels of up to 235 to 236 decibels, Rens 1 micropascal at 1 meter. The most powerful biological sounds produced by any animal, confirmed across multiple independent acoustic studies. Foraging clicks are detectable by conspecifics at roughly 10 to 16 kilometers. Slower social clicks carry further still, potentially to approximately 60 kilometers in favorable conditions. The acoustic system provides enough detection range that an approaching pod faces a group that is already responding, already beginning to compress and orient before first contact. Whether the formation is always fully assembled before orcas arrive isn't proven in every case. But the detection capability and the documented behavioral responses it triggers substantially reduces the window for a surprise attack on a dispersed group. Which brings the analysis back to the disengagement question and what the evidence actually supports. That observation is the closest the peer-reviewed literature comes to articulating what drives orca withdrawal. When the formation holds, each attack wave runs the risk of contact with the perimeter's fluke barrier without achieving separation. Over 16 bouts in California across 4 hours, that attrition was substantial. And even then, only one of 9 sperm whales was taken. Multiple encounters where the formation held ended without a confirmed kill. Sri Lanka, 2013. Approximately 30 minutes. Orcas disengaged. Outcome uncertain. Bremer Canyon, 2024. The orcas moved off down the shelf edge. Sperm whales remained grouped at the surface for an hour afterward. Tucker's report notes the sperm whales appeared to relax only after the orcas had gone. In none of these cases does the record tell us what, precisely, tipped the orca's internal calculus. The framing of orca withdrawal as a rational, cognitive cost-benefit decision carries more inference than evidence. What is observed is the behavior, and the behavior is consistent. Prolonged attack, formation maintained, departure. Orcas are documented abandoning hunts in other contexts. In Iceland, pods leave feeding events when conditions change. Energy expenditure studies confirm that hunting decisions involve energetic trade-offs. And the broader predation literature shows orca populations do update their behavior based on prey lethality. Off South Africa, documented presence of liver-extracting orcas has been followed by measurable white shark site abandonment, suggesting predation risk shapes where apex predators operate. Whether sperm whale-experienced pods disengage faster in subsequent encounters with the formation isn't directly documented in available literature. The specific learning claim isn't established. What is established? When the formation holds, orcas leave. When enough adults maintain the perimeter, separation becomes expensive enough that a proportion of attacks end without a kill. The formation converts the orca's tactical problem, find one isolated animal, direct force at it, into an attrition problem that costs time, energy, and physical risk for each attack wave, across an unknown number of bouts, with no guarantee of separation at the end. The California encounter of October 1997 is the clearest quantification of that cost. 35 killer whales, 9 sperm whales, 4 hours, 16 attack bouts, 1 kill. 8 survivors of a sustained assault by the ocean's most effective cooperative predators. That is what the formation extracted from an attacking pod with overwhelming numerical advantage. The geometry has been named and documented since Nishiwaki described it in 1962. It has been observed off California, Sri Lanka, Oman, the Gulf of Mexico, the Galapagos, and the Bremer Canyon. Its structure is consistent across every account. Calves in the center, adults facing outward in a spoke pattern, tail flukes aimed at every approach vector, and active rescue behavior for any individual pulled from the circle. The formation isn't a product of individual courage or exceptional strength. It's a spatial solution to a tactical problem, one that denies the prerequisite for the attack and forces the attacker to either sustain heavy attrition or withdraw. The sperm whale isn't faster than an orca. It isn't more agile. A pod of 8 or 9 adults against 35 attackers has no individual size advantage against each attacking animal. What it has is a formation that has been working for long enough that it shaped the literature of marine mammal predation, and which continues to be documented in the field every time a pod holds its circle and the orcas eventually move on. The orcas don't lose the fight. They stop fighting a problem the geometry has made too costly to solve.